Hi everyone, this is Mr. West. I'm making a custom video today, Khan Academy tutorial, on use similar triangles. This was requested by a commenter called YouTube Studio. So this video is for you, and if you need your own video made, go ahead and check it out in the comments. Leave a comment on what you need done, and I'll make a video for you. This particular one's kind of tricky, and that's why I'm assuming they left a comment needing help with it. This is use similar triangles. Now, we have here this little triangle. This is a right triangle, and it's got another smaller one inside of it, and actually splits it up into 3 triangles. I'm going to show you real quick. And we know they're all similar because they share sides. Now, normally not all right triangles are similar to each other, but if they share a side, like there's a triangle within a triangle, you can call that triangle inception, we have similar triangles that are created. So the green one is similar to the blue one, is similar to the purple one, okay? That's kind of a cool thing about this particular concept. But the only ones we need to worry about, well, let's figure out which ones we need to worry about. We see that it's asking us to find the area of ABC. We want to find the area, so there's 2 measurements we need. We need to know this base. If I could draw a straight line, that'd be great. There we go. And we need to find this height, okay? Base times height. Let's review that formula. Area equals 1/2 base times height. So we're looking for B and we're looking for H. We only have part of the base and we don't have the height at all, but we can get there. And this is how. Well, we got to recognize first that we have this green triangle formed here. This little one. I called this the small triangle. Okay, that's a triangle, not a letter. Okay, and then we have this medium triangle that's formed here. Why do I care about this medium triangle? Well, this medium triangle and the small triangle both have a measurement I'm interested in, and that's H. Okay, this distance right here, that's what I need to know. That's for that guy right there. Now I also need to know this entire base. And as you can see, this little side right here incorporates that base. Okay, so the blue triangle has one of the measurements I need, and the green triangle has one of the measurements I need, and they both combine to give me my 3rd measurement. Okay, if I use the big triangle, the reason why I'm not using the big triangle here, the big one, is because yes, it has the base, but it doesn't incorporate that height that we need for this problem. So I'm only using the blue and the green triangle. I call it the small and the medium and then the big, but we're only using small and medium. Now, we can compare sides. Because they're similar triangles, we know that they're proportionate. Okay, so the short side for the small one is going to be proportionate to the medium side. Okay, so short to medium for both these triangles. Okay, it's equal proportion because we know they're similar. They just might be a different scale. If this one's 1/2, this one might be 2/4, which reduces to the same proportion, right? Okay, that's just a quick review of similarity. Now, what is the short side for that green triangle? The short side is 1.8. Okay, this is what I'm defining as the short side. And the medium side is RH. Okay. Now, over here in the medium triangle, our short side is RH. And then our long side, we don't know what that is yet. So I'm just going to define it as, I'm going to call that L for long side, okay? I'm looking for that still. I'm going to put that at L. Now, the reason why I'm showing this right now is because this is a concept called the geometric mean. Anytime you have a proportion and you have the same letter, number, variable, okay, diagonally across like that, that is called a geometric mean. I would write it out, but it takes too much time. Geometric mean is what it is, and it's a great way. But the thing is, you need only that one letter variable to be the only variable. So we have this L here, and we need to get rid of it. We need to find that L, or we need to find that H. Okay, we only can have one variable here. Now, the H is actually pretty easy to find. The reason why it's easy to find is because we can use Pythagorean theorem with the green triangle. Okay, here we have C. Whoops, wrong pen. This is our hypotenuse. We have a short side, and we have a long side. A squared plus B squared equals C squared. So really, I should have started. I could have led with that. I mean, it still works either way, kind of introducing that. But A squared plus B squared equals C squared is going to give us our H, and then we can complete our proportion that we need because we can't use it with 2 variables. So our short side is 1.8. We're going to have to square that. Plus we can call this H because that's our height squared, and that's equal to C squared. Oh, but we know C. C is 3. Okay. Whoops. There we go. Okay, 9 equals, and then we have 1.8 squared. Don't know that one off the top of my head. So we got 1.8 squared. That gives me 3.24 plus H squared. I'm going to subtract 3.24 from both sides. When I do that, hold on. Nice. Okay. I get 5.76 equals h squared. This is a doozy. So if you get this one assigned, good luck to you. Hopefully this video helps. And then I need to take the square root of both sides. Okay, so let me take that square root. I always just like taking my calculator, raising it to the 0.5 power. Okay, so like 5.76 on my calculator raised to the 0.5. It's less keystrokes. Okay, and it's the same thing. I talk about that in other videos. So anyway, 2.4 is my height. And now I can change this h here, call it 2.4. Erase this one, 2.4, and voila, I have only one missing variable. I still have that geometric mean I was talking about. These numbers are the same. That's called the geometric mean. And I'm ready to proceed. I'm going to cross multiply and then solve for L. So I cross multiply here, I get 1.8 L equals 2.4 squared. So I get 5.76, and now I simply divide by 1.8 to both sides, divide by 1.8. And I get 3.2. I'm not even close to being done. That's the sad part. But look, we got most of it there, okay? We know now that this is 1.8 right here. This is 3.2. So we got the big side, the base. That's that one right there. We got that one, and that is those two added together, which equals 5. So now I have the base is 5, okay, right here. This is 5. I'm going to erase that. I didn't mean to go custom ink here. There we go, 5. We know the height. That is 2.4. And we just do 1/2 base times that height. Okay, so let's go 5 times 0.5, or 1/2 times 2.4. And I get 6. What do you know? Nice even integer here. 6 square units. So the square units. Okay, and there we go, 6 square units. Now you're probably thinking, oh my gosh, I can follow along with you. This is what everyone says. I can follow along with you, but as soon as I get to this problem on my own, I freeze because I don't know what to do. Well, let's try to break it down again. Now that we have the basics, the more times you do it, the better you get at it. In the diagram below, RA is parallel to ET phone home, and RT is 21 units long. Okay, so let's fill in some things here. Okay, so we have RA is parallel. RA is parallel to ET, and then we have RT is 21. Okay, this is different. I'm actually kind of thrown off guard by this problem. This is different than the other ones. Where's this? RT is 21. So this whole distance is 21. Okay, and it says that this measurement here, I think RS is 21. Is that what it's saying? Or is this saying that that is the 20? Oh, it's saying that R. Okay, that's what it's giving. Okay, so if I go back here, that 21 is represented already. Okay, cool. Now, we're asked to find the length of ST. Okay, so we should probably highlight that. Let me get rid of some of this stuff. We're looking for ST. We're looking for this right here. Okay, so what do we know about this? We know these triangles are similar because we have vertical angles here, and because these are parallel lines with the transversal, we have opposite interior angles. So these are not corresponding. They are similar triangles. Okay, so I'm going to redraw them. Okay, I'm going to keep that one oriented this way, and then I need to shift this guy's orientation, the blue one. I like to draw it so it's oriented in the same way. I find that a little bit easier, okay? So then if I flip it over like this, where S is on top, okay, this is a little challenging. It looks like it's going to be slanted this way. Let's see. I'm gonna flip over my iPad. Okay, yeah. So I flip this over. All right, and then S is here. Then we have R is here, and then A is here. Okay, and then we have our 3 lines here. So it's oriented the exact same way. Okay, this time though we have this is 6. So we have 6 to 8 right there. That's our proportion. This one's actually easier than the other one because we don't have to worry about the right triangle similarity, which is a tough topic on its own. If you need help with that, I have a plethora of videos just on that. Let me know if you want me to locate those for you, but you can search it. Anyway, we know the green triangle. So we know the green to the blue triangle, or the small to the big, is 8 to 6. Okay, we know it's 8 to 6, which we can reduce, divide by 2 to both, and we get 4 over 3. So we know it's 4/3 bigger, okay? Now, the problem is this 21 is incorporated into both these triangles, okay? So we know that ST, okay, we're going to call this x. Okay, and then we have this r, and that's what we're trying to find, is that st. Okay, so we're trying to find that, and we know sr, we'll call that y. We know x plus y equals 21. Okay, we also have another relationship between x and y. We know x to y is equal to 4 to 3. Okay, I should really kind of change the colors here. I think that would help. Let's change all the x's to green. Boy, I can see why you requested this video. This is a kind of a tough one. Okay, now that I have x plus y equals 21, makes sense, right? We have those two lengths added together equal 21. That's one of our givens. And we know that x to y is 4 to 3. It's that proportion relationship. So I don't like it written as a fraction, so I'm going to actually cross multiply here. So I get 3x equals 4y. That makes it a lot more comfortable for me to work with, okay? 3x equals 4y. All right, so what should I do from here? Well, I can basically solve this using system of equations. So we have two equations, 1, 2, and actually I'm going to use substitution. I think that's probably the easiest way to go. So I'm going to solve for, let's just do x. So I'm going to divide both sides by 3, and I get x equals 4 over 3y, or 4y over 3, however you want to put it. And I'm going to substitute that in for x. Okay, so this was my x value. It's equal to x, so I'm going to substitute it in, and really, I'm going to write it as 4, I'm going to put 4y over 3 plus y, well, I'm going to change the color there, plus y equals 21. Now, I don't like it when there's a fraction. My favorite thing to do, and there's multiple ways to solve with that fraction. You could do 4 over 3 plus 4, plus 3 over 3. I'm guessing most people are going to do this. I'm actually going to do it this way, but I'm just saying you can multiply everything by 3. Okay, even in the 21, and it makes it easier in my opinion. I'm guessing not a lot of people like doing that, but that's my preferred method. But I'm guessing most people are going to want me to change this to 3 over 3y. It's the same value as 1y. And then I can add these two together, and I get 7y over 3. Keep the denominator the same, add the numerators 4 plus 3, and that's equal to 21. Okay, I'm going to have to erase some space here. I'm just going to go arrow, just so you can see all my work still. Arrow. Okay, so then I'm going to multiply both sides by 3. Okay, that gives me what? 63 equals, that cancels, 7y. And then divide both sides by 7, and I get y equals, what is that, 9? Oh, dang it. I should have solved for the other one. I should have solved for y so I could plug in and find for x. Regardless, I can still find it. So I know y. I should have solved for the other one. Okay, anyway, so we have x plus 9 equals 21. And now I need to think to myself, okay, what plus 9 equals 21? I can subtract 9. Okay, and I know, boy, I'm having a brain fart. 12 equals y. X. Sorry, we're solving for x. So 12 plus 9 equals 21. That's that missing side right there. And we know that 12 over 9 has that 4/3 relationship. So the answer is st, which we called x, is going to be 12. It's the bigger side of the triangle. Okay, probably running out of time here. Maybe I'll just kind of set up the next one. I'll do this one maybe quick. Okay, FOR is an isosceles. OR is a parallel line to AN. So let's see, OR. Okay, and it looks like it. It's just, sometimes it's nice when they draw it so it looks parallel. Look at those straight lines. Okay, so we have AN equals blank units. We're looking for AN. That's our goal. Okay, so let's highlight this one. I don't think I'm going to get time to, I don't want this to be too long, so I don't think I have time for a fourth one, but I'll go ahead and do 3. Okay, so we're looking for AN. Let's go ahead and call that X. Real creative, I know. All right, so we know they're parallel, so we know that these triangles are similar, and we're given that it's isosceles, so we know that, okay, so we know that this is also 7 over here, and we know the full distance is 10. This is good, okay? So really we want to know about these similar triangles right here. This big red one and this blue one. We always want to set up triangles if we can. 2 different triangles. So we have the red one, which we'll call the big triangle. And we have the small one. Okay, so big to small triangle. Okay, now we're interested in X. So we know that, let's see. So actually, let me rearrange this actually. So we're going to compare the big to the small, but we're going to do it across the equal sign because we're comparing more than one side for each. We're not just comparing one side. So we're going to put the small triangle over here, and we're going to put an equal sign with a proportion, okay? Now, in the proportion, we're going to compare 2 sides. We're going to compare we'll call it the left side. Okay, it doesn't matter. We could call it a side, and we're going to compare it to the base of both of them. Because these are proportionate triangles, the side to the base is going to be the same for both of them, okay? So, for example, with the small one, we're good to go there. We have measurements of that triangle. Let me redraw it. It's always good to redraw these, okay? So I'm going to just kind of orient it the same way. We know this is 7, 7 because it's isosceles, and we know that's 11.2. So we know we're going to go side to 11.2. We know that proportion. We're cooking right now. Now, for the big one, we know that side is 10, and we know that base is x. We're trying to find it. Okay, so this one's actually a pretty simple one, and now we just cross multiply and we go from there. So we get 7x equals, what is that, 112, and then we divide by 7. Oh gosh, what is that, 13? No, divided by 7. How embarrassing. X equals 16. I should know that. All right, so x equals 16. That's all it takes for that one. That was actually pretty quick. And then I'm just going to look at it. I'm going to peek at the next question, peek at it. Okay, it looks like it's going to be pretty easy. All right, so same process with them. This one, we're asked to find BL. Okay, BL, this big length. This one's slightly nuanced. You guys are getting a bonus problem today. Slightly nuanced because we're looking for that whole length there. We'll call it x, and we're given a part of it. Okay, again, we want to get in two triangles. We're going to have a big one. I should keep it red. Just to be for continuity. So this is a big one here in red. Okay, so we have our big triangle. Okay, and we're going to compare it to the small one, which I guess we're using blue again. Okay, so our small triangle. And I like highlighting it just so you're aware of what I'm comparing. Whatever, I'm going to highlight it in blue. Hope you guys don't get mad. Anyway, so here we're going to compare two sides. What sides should we compare? Well, we don't know. The problem is with this is we don't know this side right here. Well, that's a question mark there. And once we find it, then we'll be able to get this side, and we can get that whole length too. I mean, that's the same length. Okay, but let's compare what we know to start. Well, we know that let's see, it's 12 and 7.75, right? And actually, I'm going to have to do this a separate way. I'm not going to actually... My initial thought was that I was going to set it up like this, but knowing that I have these two sides, I know how much bigger it is. So I'm going to actually go a little bit back. No, I'm not. I'm going to stick with this. And what am I going to do? Sorry, I'm kind of thinking out loud. First time I'm seeing this problem. I'm going to do the same thing. I'm going to compare the side to the base for both of these. Okay, so I know my base for the big triangle is 12, and I don't know my side. I'm going to call that missing letter x, but I'm going to call this side x. I'm not going to call the big side x. We'll get to that eventually. We just know we add x plus 5.1 to find this big side. Now I know what I'm doing. Okay, there we go. So I know that the big side is x plus 5.1. There we go. Now we're cooking. Now the base of the small one, 7.75. I should have made that in red. Sorry. Here we go. Got it. Here we go. Bear with me. X plus 5.1. Okay, now for the small one, we don't know that side length for the side either. We call it x. So what we're going to do here is we're going to cross multiply, and we're going to solve. So we have 12x equals 7.75 times x plus 5.1. A lot of students struggle with that. That is distribution there. Okay, so I need to distribute first 7.75 x plus 7.75 times 5.1. Okay, and I get 39.525, kind of ugly there, equals 12x. Now, I need to get my x's together, so I'm going to subtract 7.75x from both sides to get my x's together, and that gives me, what is that, 4.25? I didn't use the calculator, 4.25, yes, equals 39.5, what did I say, 525. So I need to do 39.525 divided by 4.25. That's a mouthful. And I get 9.3. So x equals 9.3. So now I can find my big side here because I just plug in right there. 9.3 plus 5.1. Survey says 14.4. That should do the trick for that long side. Hit me. Come on. There we go. 100%. So that was a bit long. Okay. But that's a grind. Use similar triangles. We went over everything there. Basically, you need a whole semester of geometry at least to do that. So if you follow along, that's awesome. Leave a comment if you need more help. If you need another video covered, leave a comment. Either way, I look forward to seeing you right here next time on Wes Explains Best.